Hello everyone. How are you all doing? How are my all champions doing? A lot of you are awake at this moment of time. That in itself is a win for you guys. So you are way ahead than other. Hi everyone. How are you? How are you all doing? I know you all must be scared because you are awake at this point of time, but do not worry. We are going this 5 a.m. this 5:04 a.m. session is held because we are here to just get a gist of what is left. Maybe I shouldn't leave anything or just grab the most important topic that are left in our there in the physics. Okay. So let us see what you all have to remember at the last amount of time. Hi everyone. Hello. Great. A lot of you are awake at this time. Great. Let's move on to our very first. We are going to see all the formulas first, right? So let's start with that most important formulas and units of the chapter electricity. Now everyone, since it's very early in the morning, we will directly jump into all the all our syllabus, and we won't talk. Okay, at 4 a.m. you can't talk to anyone. Okay, let's concept is Ohm's law. We have two formulas for Ohm's law. We have first Q equals to IT, a very important formula that you need to remember in electricity. Q equals to IT, and then Ohm's law is V equals to IR. Coulomb and ampere are the units. Then potential difference, work done per unit charge, volt, electric power, P equals to V square by R, I square into R, V into I, and its unit is watt. Electrical energy, E equals to power into time. Its SI unit is kilowatt hour. Also you can find this in joules as well, but if nothing is written, they didn't mention if you have to find in kilowatt hour or joule, then it's better to find in kilowatt hour because the SI unit is kilowatt hour. Okay, then heat energy, H equals to I square RT into V square by T into R divided by R. Also this is V into I into T. Its unit is joule. Resistivity, rho equals to RA by L, and its unit is ohm meter. Resistance, R equals to rho L by A, we all know, and this is ohm. Then next, moving on to the chapter, again electricity, we have two things, series and parallel. In series current remains the same, voltage is different. In parallel it is inverse of that. Formula is addition of all the given resistances, and in parallel it is 1 by Rp, that is LCM of all the resistances. Then move on to the next. We have magnification formula for height of image by height of object. Then refractive index N2 by N1. Mirror formula 1 by V plus 1 by U equals to 1 by F, very easy. Lens formula on the other hand, 1 by V minus 1 by U equals to 1 by F. Now I remember most of you did a mistake yesterday. We had to use mirror formula, you used lens formula, right? Remember? So don't do that here. Okay, it's fine, I get it, you all are scared. In the paper you might panic, but do not at all do that here. As soon as you read the question, you see if it's a mirror or a lens and write it down on your answer sheet. Okay, in big words that this is a lens, not a mirror. Okay, magnification. Now for mirror we have minus V by U, for lens we have plus V by U. If the magnification sign is positive, that means the nature of image is virtual and direct. If it's negative, that means real and inverted. Again, positive, virtual and direct, negative, real and inverted, same for lens and mirror. Next, these are all the sign conventions, right? The object distance at infinity, the image will be at focus, highly diminished point size, real inverted, and U will be negative, V will be negative, and height will be negative. So this is for concave mirror. You go through all of this, right? Go through all of this. I have already provided you all the PDFs of this. Right, everything is mentioned in that PDF, so go through this while just before you go into the exam hall. This is same for convex mirror. Again, infinity at focus, at any point between infinity and pole, it will be, the image will be between P, pole and focus. And in this, virtual and direct, virtual and erect. Okay. Next we have again convex lens. See all the image object positions, size of the image, nature of the image, form, sign convention. I've given you everything. Just go through them. Okay. Next, concave lens, again 2 cases just like convex mirror. Okay, then magnetic effects of electric current. Some are straight conductor. We have magnetic field due to straight conductor is, if the current is in upward direction, it is concentric circles. Okay, in downward it is concentric circles. Factors affecting, very important. This is a very important point, right? Very important point. Factors affecting magnetic field. Current, 1 by distance. Distance is inversely proportional to the strength of magnetic field. Okay, then inside closed loop, if the current is clockwise, the direction of magnetic field inside the loop will be inwards. If the current is anti-clockwise, direction will be outwards inside the circular loop. It is directly proportional to current, inversely proportional to radius, inversely proportional to distance from the loop. Then solenoid, inside the solenoid the field goes from south to north, outside north to south. We know that. The factors affecting are current, number of turns, very important, and 1 by distance from solenoid. Done. These are your formulas. Moving on, we have one formula. This is power of lens. 1 by focal length when focal length is in meters, and 100 by focal length when focal length is in centimeters. Done. When you write diopter, that is for focal length equals to meter. Right? If sign is positive, then that is a convex lens. If sign is negative, that is a concave lens. Very important. Again, very important point. If power is negative, that means it is a concave lens. If power is positive, that means it is a convex lens. Okay? Done. Okay, everyone, let's move on. I've got you some questions, not more, some questions that I think you might need to do again. Now, refractive index is a topic that most of you are fear from, right? They get scared from. So how do you look into that? Just remember one formula, N12 equals to N1 divided by N2, that is refractive index of 1 with respect to 2. 1 with respect to 2. Right, this is the formula. Then this will equal to V2 by V1, which will be equal to lambda, that is your wavelength. Yes, they can ask this, right? Lambda 1, lambda 2. This is directly proportional to velocity. Lambda 2 by lambda 1, lambda 1, and this will be equal to sine I divided by sine R. Done? Done, everyone? This is the refractive index of of 1 with respect to 2. That means the ray is going from 2 into 1, second medium to first medium. This is ulta. Okay, great, very good. Now let's look into this numerical. The refractive index of a medium X with respect to medium Y is 3.2. The refractive index of medium X with respect to medium Y is 3.2. I won't solve all the question. I'll just tell you how to do this, so that if any kind of question comes, you'll be able to do that. Okay. And the refractive index of medium Y with respect to Z is 3.4. Right, first we have to find the refractive index. We have to find the refractive index of medium Z with respect to X. We have to find the refractive index of medium Z with respect to X. So now what you have to do, you have to analyze these two. That how should I do this? Should I divide these two? Should I multiply these two? What should I do so as to get this value? Now this is NZ divided by NX. Right, if I see this, then I'll get NZX. If I divide this, let's say NX by NY, right, divide by NY divided by NZ. This goes in the numerator, this goes in the denominator. So that means NX into NZ divided by NY into NY. This doesn't make any sense, right? Let's multiply them. If we multiply them, NX by NY into NY divided by NZ. So this cancels out. This becomes NX by NZ, and then if I inverse them, this becomes NZ divided by NX, and that is what I want. right? Understood how we go through the question? So now you can just write this. You can multiply these two, 3.2 into 3.4, 3.2 into 3.4, and whatever the answer comes, that is nx by nz, but we need nz by nx, so we will inverse the answer. We will inverse the answer to get nz by nx. Done? Done, everyone? Okay, great. Now what else? If the speed of light in medium x is 3 into 10 raised to power 8, speed of light in medium x is 3 into 10 raised to power 8, and calculate the speed of light in medium 1, y. Calculate the speed of light in medium y. So we just studied a formula, and n1 by n2 equals to v2 by v1. So can I write nx by ny will be equal to vy by vx. Now I have this, I have vx, can I find vy? Very easy, right? Okay, let's move on to the next question. Role of ciliary muscles. This is a very important topic or something, because they might ask you this. Why? Because the role of ciliary muscles is to adjust the curvature of eye lens, definitely, but for distant objects, the eye lens becomes thin. The eye lens becomes thin, something like this, right? And its focal length increases. More the distance, this is a distant object. More the distance, more the focal length, and hence the eye lens is thick to see the distant objects. Then for nearby objects, we have eye lens becomes thick. It becomes thick, something like this, right? And the focal length decreases. Then that is it. Okay, next we have resistance. Now lots of you guys have problem in resistance circuits, right? Yeah, I know. Resistance is basically when you combine a lot of resistance, you have to figure out what's in parallel, what's in series, combination of all these. So how do you do this? If you look carefully at your resistance or your circuit, you'll find something that is easy to solve in the first step. So see, in this whole case, these two are in series. So if I solve this, in here I'll only get one resistance, and then these two are in parallel, and I will get one resistance in place of whole of this, and then these three will be in series. Easy. Then if same these two are in series, first I can add them, then the resultant comes, these two all will be in parallel. Easy. Okay, same, these three now are in series. You can clearly see, if you solve them, you'll get 36, and so this is your final circuit now, and this is 12. So by 12 and 36, they are in parallel. We can use the parallel formula. See, I got you three big circuits, right? But they look the same. They can be solved the same. If you get something else, no, they are not in series. Something like this. So what will you do? So in first, see, you cannot solve these two or these two, but these two are in parallel. If you solve these two, the resistance, the circuit will become something like this. Right? Okay, ma'am, but there were many big circuits, something like this. Okay, let me make a big circuit. Let me make a very big circuit for you guys. Okay, done. Now this is big, this is also big. Okay, this is also there, this is also there, and then something from here, let's say this is there. Now it's hard. Now it's definitely hard. So what you do? Again, these two are in series. Right? So you solve them. This becomes 1, and there is one more circuit. This becomes one more circuit, and then we have another circuit and all the other circuit, right? All the other circuit. This is simply in series. Now these two are in parallel, these two are in series. Solve them. What will you get? You get one circuit here and one circuit here. How will you get that? Wait a second. You just don't panic. Okay, so see, how will you get this? Let me mark this. Okay, if you solve this, what will happen? This one, 2, third, and this we solved, right? This and this circuit, first and second, we already solved. So in that place, one circuit will be there and another, this circuit will also be there, correct? This circuit will be there, something like this, and then these two are in series. So instead of 2, we can only place 1, and then one more resistance and one more resistance and battery. This was there. Any doubt? Then you can solve these two. These are clearly in parallel, right? These are clearly in parallel. This was also there. This was also there. So you can even solve these difficult. If you solve this, there will be only one resistance here, one here. So this will be something like this. This will be something like this, right? So now can you easily solve this? Now can you easily solve this? Now this is not tough. This is not tough. All these three are in series. All these three are in series. See, I know it might be a lot, but if you think these high resistances are a bit of a task for you, leave them for now. This is the exam day. Don't need to dive deeper into so many hard questions. It's just for someone who wants to know how to approach the question in a faster manner. Okay, if you don't, till here you can easily solve these small resistances. It's very less chance that this big of a circuit will come in your 10th board. No chance. Okay, no chance. So leave that here. Let's move on to the next. Now some important topics I have got you from each chapter. From electricity, this is basically electrical energy is a very important topic. The units are kilowatt and joules, but it's a very, very important topic. Electrical energy is basically power into time, right? It is basically power into time. And then this what do you say, conversion or this relation is very important. Sorry. 1 kilowatt is equal to 3.6 into 10 raised to the power 6 joule. Then cost of electrical energy is very important. 1 kilowatt hour is always equal to 1 unit, and you will be given the rate of 1 unit. That means you have to find electrical energy in kilowatt hours. Okay, then cost of electrical energy again, okay, very important. Then resistance circuits, we saw how to solve them just now. Sorry, we saw how to solve them just now. And then some of the wires, tungsten we use in bulb, nichrome wires we use in heaters, we use in geysers, copper is a good conductor of electricity, and all these things you need to remember as well, because they might ask some conceptual questions on that. They might, less chance, but they might. Okay. Next is magnetic effect of electric current. Now we have different current carrying conductors. First is our straight wire, then circular loop, then solenoid. Some of the factors are all of them are directly proportional to current, inversely proportional to distance, inversely proportional to radius of the loop of the solenoid, and then number of turns of wire. Okay, number of turns of wire of solenoid. This is a case of solenoid. This is a case of solenoid. Done. Then we have right hand thumb rule, which is used to find the direction of magnetic field. Thumb in the direction of current, curling of fingers give the direction of magnetic field. Then Fleming left hand rule to find the direction of force, where thumb gives the direction of force, index finger gives the direction of magnetic field, and middle finger gives the direction of current. Done. Then some of the topics, overloading, when so many circuits, so many appliances are connected in a single plug, we are trying to collect more current than the wire actually hold. Short circuit, when live wire comes in direct contact with the neutral wire. And household wires, live wire, neutral wire, earth wire. Earthing is very important. Earth wire, the main function is to collect all the excess charge on the metallic body and pass it down to the earth. Right? Then we have household circuit. We all have studied household circuit, so remember that as well. Okay, then human eye. From human eye, power is very important. While using 1 bifocal length is the basic formula, but 100 bifocal length when focal length is in centimeters. Okay, Then lens formula again, 1 by f equals to 1 by v minus 1 by u. Now near point and far point numericals. Whenever they are given that near point has shifted or far point has shifted, then the new near point or the far point given. Listen to me very carefully. The near point of Aditi has shifted to minus 15. So that minus 15 will be v, will be image distance of the corrective lens. Of the corrective lens, the new near point or the far point will be the image distance of the corrective lens, and it will be in negative. For u, for object distance, in case of near point, it will be always minus 25 centimeter. For far point, it will be always infinity unless it's given. Okay, next we have function of each part of the human eye: cornea, pupil, iris, aqueous humor, vitreous humor, what else is there, lens, retina, cords and rods, which are light sensitive cells, which convert light into electrical energy, optic nerve, which passes those signals to the brain, and all those. That is it. Ciliary muscles, very important, we just studied. Okay, and then moving on to a very important thing, that is in our chapter light, we know all the important things, we have studied everything, but very important is those 4 optical instruments we use: concave mirror, convex mirror, concave lens, convex lens. Now see how do we solve these. Okay, there will be a link in the description that you can click and get all the formulas of physics, reactions of chemistry, and diagrams of bio for your last minute quick revision. Okay, click that link. You just have to fill your phone number and the PDF will be there, right there with you in just 1 minute. Okay. Next, concave mirror. Now object and image distances, we have 6 cases. Object is at infinity. Let's just see them in the here. This is a trick we use. At infinity, the image will be at focus. Beyond C, image will be between C and F. At C, image will be C. Object between C and F, image will be beyond C. Object at focus, image will be at infinity. Object at between focus and pole, the image will be somewhere here behind the mirror. Behind the mirror. Done. Let's see how to make these diagrams. Oops, sorry. Okay. First case, the object is at infinity and the image is at focus. So object is at infinity, parallel rays are coming, all these are getting reflected, the image is being formed at focus. The size is point sized. Nature of concave mirror is always real and inverted unless it's a 6th case. Okay. Sorry. Then the object is beyond C. We got the object nearer to the concave mirror. This is beyond C, and one ray goes parallel, passes from the focus after reflecting back. Another ray goes through the focus, reflects back, goes parallel to the principal axis. Oof. And this is the image between C and F. The size is diminished, nature is real and inverted. Next we have at C, the image will be again at C, one ray parallel passing through focus, another ray passing through focus, coming parallel, and the size will be same as object, nature will be again real and inverted. Same for this, I think you all know this, right? Object between C and F, rays go same like this, the image will be beyond C, size will be enlarged, nature will be real and inverted. First to 5th case, nature will be real and inverted as the image comes towards the concave mirror. As the image comes towards the concave mirror, the size of the image increases. The size of the image increases. Done? Remember that line just. Then at object that F, the image will be at infinity, or either it will be, you can write not formed, right? One ray goes parallel, passes through focus, another ray goes from the pole and reflects at the same angle of incidence. Highly enlarged, obviously at infinity, again real and inverted. Now the 6th case, very important, object between pole and focus, and the image will be behind the mirror. The image will be behind the mirror. One ray goes parallel, goes to focus, and the another ray goes into the center of curvature, in the direction of center of curvature. This will be enlarged and the nature will be virtual and erect in the 6th case of concave mirror. Done. Then going on see, so first to 5th case, the nature of image is real and inverted and it is of all sizes. For 6th case, it's an exception, the image will be virtual and erect and it will be enlarged. For convex mirror, all the time the nature will be virtual and direct, but the size will be diminished. The size will be always diminished. It's a diverging mirror. Concave mirror was a converging mirror. So object at focus, the image will be at focus. The rays actually comes and reflects back, but we extend them backwards to see that they are coming from focus. Right? Then two objects, the second case, object is anywhere between infinity and pole, so I placed object here. One ray goes parallel, diverges, but we extend back, it is passing through focus. Then the another rays goes, diverges back, but we see it is passing from the center of curvature. So this is where the image is formed. Then both cases of convex mirror done. Then moving on to, again, first two cases, both are virtual and direct, always diminished. Then we have sign conventions. Left hand side distances are negative, right hand side distances are positive. Right hand side of the mirror. Then height above the principal axis positive, below the principal axis negative. Exactly. Left hand side negative, right hand side positive. U is always negative, we know that. Now in case of virtual and direct image was formed on right hand side, we know that, right? So for virtual and direct image, the image distance is positive. For real and inverted, image distance is negative. In case of mirrors, focal length of concave mirror negative, radius of curvature again negative, height above positive, below negative. Then moving on, sign convention of convex mirror, again left hand side negative, right hand side positive, height above positive, height below negative. Now again in case of convex mirror, always virtual and direct image is formed, so always the V will be positive and U will be negative. Focal length of the convex mirror is always positive. Okay. Then subscribe the channel if you are here at 4 AM. So images formed by concave and convex mirror, a quick grasp of all this. Concave mirror, focal length always negative. Convex mirror, focal length always positive. We form real and inverted image, virtual and direct image, always forms virtual and direct image. U is always negative in all the cases. V is negative for real and inverted, we just saw. V is positive for virtual and direct. V is positive for virtual and direct. Then magnification for real and inverted will be negative, for virtual and direct positive, for virtual and direct positive. Then next move on to lenses. For mirrors, okay, the magnification formula is minus V by U, height of image divided by height of object. If the magnification is negative, the image will be real and inverted. If the magnification is positive, the image is, this is for magnification, the image is virtual and erect if the magnification is positive. Next moving on to, we have two lenses, convex lens, concave lens. Shape of convex lens is something like this, concave lens is something like this. Next moving on to first convex lens, again has 6 cases just as concave mirror, just the names are changed. There we used C, here we are using 2F2. Right? So first at object is at infinity, parallel is coming. Now they are passing through the lens, so they are not reflecting back, they are passing through the lens, so they are passing through and converging at focus. Same, everything is same. Image will be at focus, size will be point size, nature will be real and inverted, similar to concave mirror. Second case, object nearer but beyond 2F1, ray goes parallel, pass through focus, another ray goes directly from optical center without any refraction, and this is my image formed, which is again what, real and inverted. The image is between F2 and 2F2 and the size is diminished. Now as we move towards, it is of same size, so make sure you are making the same size. Object is at 2F1, image will be at 2F2, nature will be real and inverted, and the size will be same as object. Between 2F1 and F1, object got more nearer to the lens, one ray parallel, pass through focus, another ray through optical center, and the image will be beyond 2F2, size will be enlarged, nature will be real and inverted. Then fifth case, at focus, the image will be at infinity, or not formed, size is high, highly enlarged nature is again real and inverted. Sixth case, the object is between f1 and O. Now in this case, just like concave mirror, this is an exception. This is a sixth case, so image will be virtual and direct, size will be enlarged. In concave mirror, the image is formed on right hand side, but in case of lenses, the image will be formed on left hand side. So this will be the image. One ray goes parallel goes through focus, we extend it back. Another ray goes into the optical center, we extend it back. This is somewhere they meet, and this is my image. Done. Next, we have a concave lens, one lens. Now instead of rays converging, they diverge. That is the property of concave lens. They diverge. So we extend them back and we see the image is formed at f1. Right? So the image, the object is at infinity, the image is at f1. In convex lens, it was at f2. Here it was at f1. The size will be point size, and the nature will be virtual and erect. Nature will be virtual and erect. Then next we have object between infinity and O. So object is anywhere between infinity and O. So this is the object we placed, right? One ray goes parallel and it diverges, so we extend it back, passes through focus. Another ray goes directly to optical center, and this is the image formed, which is again virtual and erect. Size is diminished, as you can see, and the image will be formed always between f1 and optical center. F1 and optical center. Great. We are done with all the ray diagrams, sign conventions. Everything is same, just one thing. In case of lenses, virtual and erect, image distance will be negative. In case of mirror, it was positive, but in case of lenses, it is negative. For real and inverted, it will be positive. For real and inverted, it will be positive. For virtual and direct, it is negative. Then everything else is same. Now for lenses, we have convex lens, concave lens, first to 5 cases real and inverted, sixth case virtual and direct, just like mirror. So concave lens, virtual and erect. Now U is always negative. In here, real and inverted, V is positive. In mirror, for real and inverted, V was negative. In lenses, real and inverted, V will be positive. Done. Then magnification is again a negative for real and inverted. Magnification is positive for virtual and direct. U is negative, V is negative for virtual and direct. V is negative for virtual and direct. U is negative, diminished. M is positive for virtual and erect. Right? And the formula will be 1 by F equals to 1 by V minus 1 by U. This is our lens formula, right? In this case, the magnification is positive V divided by U. Positive V divided by U. In case of mirror, it was minus V by U. Done. Everyone who spoke for this much long. Okay, great. Everyone understood? These are some of the most important topics, most important things I thought we need a revision of. Any question come, you have to just calm down and you have to start from the very basic. You think like teacher doesn't know anything. So start from the very basic, especially the questions that you don't know. That you don't know the answers of the question, start from the very basic and build it from there. There can be some unexpected questions. Again, start from the basic. You know what the concept is used, right? So start from the basic, think about it, go towards it. Go towards the higher level. Right? Okay, that is it for this live. One more thing that I wanted you to tell, how to make these diagrams. First, ray diagrams, how to make this. Just for mirrors, it is a bit difficult, I guess, than for lenses. So you have to make curvature and focus first. But what you have to do, every time, just when you are making an image, let's say this is my concave mirror. Now the case is between F1 and between F and center of curvature object, right? So just draw with a pencil that okay, this is somewhere I'll take focus and this is somewhere, this is center of curvature. Now object is here. We know the image should be beyond C. The image should be beyond C. Now a lot of people do tell you that make the image first. Don't make the image first. Okay, that is in the case of at center of curvature. I'll tell you in a point. So what you do, one ray goes and it passes from focus. Focus is kind of fixed. Another ray goes through the focus, passes through the passes parallel. Now this is correct. Now this is correct, but assume that these two rays actually meet somewhere here. They meet somewhere here. That is wrong, right? So then you can shift your center of curvature to somewhere here. Okay, make the focus. First is make your mirror. Make the mirror. See, this is very important point. Make the mirror. Then second, draw the focus. Point out the focus. That is it. Point out the focus. That is it. The third part is now make the rays. Make the rays from the object. Do not make the center of curvature first. Do not make center of curvature first. Always point that out later. After completing your diagram, then mark that, okay, now here will be my center of curvature. Then in case of at C, in case of object, let's say at C, now we know it will be of same size. So in this case you have to be very careful. At the center of curvature, make the object and make the images of same size. Now what you have to do, now one ray goes parallel, now another ray should also go parallel. Listen to me very carefully. Another ray, just make these two rays. This is going and this is coming. Now make sure that these two are connected. These two are connected, and then these two are connected, and they are passing from one point. That is my focus. See how easily the diagram is made. First, make this ray. Don't make the another one. Make this one now. Make this parallel ray. Now connect these two. Connect these 2 points. Done. Good. Now these are some 4 AM hacks, right? So make sure you make your image, you make the ray diagrams something like this. And similarly it goes for lenses. See, in case of at C, at F1, right? Now what you do, take your scale from the lens at, let's say, 5 centimeter, you made your 2F1. So at 5 centimeter also you have to make your 2F2. This should also be 5 centimeter, right? Now make an image here and make an object here of the same height. See, here I have a little bit, the height is gadbad, right? So make the height first and then connect these 2 points with your scale. These 2 points with your scale, and don't make the lens first now. Make sure, see, if I connect these 2 points, this is passing from somewhere here, right? So I'll make the convex lens here now. Okay, some things you have to do in order to make the ray diagram correctly, right? Now the best thing that you can do actually is to take a compass. But if you have time only, make sure your pencil and the compass is sharpened, your compass is exactly open, that is fine, but the pencil is already in the compass and the pencil is sharpened. So in that case you can make your lens or your mirror with the compass. That will be very helpful. Okay, that is it. All the tips, all the tricks. Make sure you leave lines after the answers. Okay, and make sure you have, right now go and check your pencil pouch. Make sure it has a well working sharpener, a well working pencil, 2-3 blue pens, your compass, your scale, and your eraser, everything, right? Done. Great, you all have that. Very good. Now it's time to finally go into the battle, go into the war, and actually win it, right? Do not panic even if some weird questions come. Let's skip it in the starting. Make sure you're leaving enough space, and make sure you're attempting the paper section wise, right? Make sure you're attempting the section wise, and do leave some space after every section, so that if you want to attempt some left out question or some left out answer, you can do that in that particular section, because if you do it in another section, marks won't be given to you. Okay, that is it for this. All the best. This is one of the final times you are studying 10th class science. So make sure you do it right and go. How do you say that? Make my naam roshan. Okay, all the best, all the very best, everyone. The paper is going to go great. Okay, tata, all the best of luck. A very happy science paper. Bye.
Hello, my class 10 students. How are you all? Today is your exam. Very good morning to all of you. Yeah, I know it's 4 a.m. and all of you are worried, scared, nervous, right? Don't be. Your Ekta ma'am is here and Aditi ma'am is also, right? So we are here for you. Do not worry, we got this. This is a quick revision of all the things that you need to know before going for your class 10 exam. Okay, so in it, I will be covering all the important chemical reactions, all the chemical formulas and color of all the important compounds that you should revise before going for your exam, because yes, something if it stick around in your head for long enough, if you study it now, trust me, it is going to stick around in your head till your exam. Okay, so don't worry, let's start. From chemical reactions, these are the reactions. When you burn magnesium ribbon in air, you get magnesium oxide. Conversion of quicklime into slake lime, this is quicklime, and when you add water to it, we get slake lime plus lots of heat is released. It is highly exothermic reaction. Carbon dioxide with water, when lime water reacts with carbon dioxide, we get calcium carbonate, which is milky. That means this is a reaction when you call lime water turns milky when you pass carbon dioxide gas through it. That milkiness is due to calcium carbonate. Okay, then you have heating. Further, if you pass carbon dioxide for long enough, you get calcium hydrogen carbonate or calcium bicarbonate, which is water soluble, and the milkiness disappears. Right? Now, when you heat calcium carbonate, what is the reaction? This is thermal decomposition of calcium carbonate. It is endothermic reaction, as you are giving the energy, calcium oxide and carbon dioxide you will get. Now, when you heat lead nitrate, what happens? It is again thermal decomposition. We get yellow colored lead oxide and brown fumes of nitrogen dioxide. When you heat hydrated iron sulfate, firstly it loses its 7 water crystallization, its color is green, and then after, if you further heat it, it converts into Fe2O3, SO2 and SO3, which has rotten egg smell, right? And this iron oxide, which is brown in color. Silver chloride, silver bromide, same reaction, the color changes from white to grey. Here it is yellow to grey. Then you have electrolysis of water. At cathode you get hydrogen, at anode you get oxygen. Combination reaction, very easy. Carbon combined with oxygen, we get carbon dioxide. Hydrogen combined with water, we get oxygen, we get water. Next, a displacement reaction. These are single displacement reaction, right? Brown color iron combines with blue colored copper sulfate, we get reddish brown copper and green color of iron sulfate. Double displacement, these are the important ones. Sodium sulfate, barium chloride combination, we get barium sulfate, white PP to barium sulfate and sodium chloride. Potassium iodide, lead chloride, which is white in color, the color changes to yellow, lead iodide, okay, plus KCl. Next, you have potassium bromide with barium bromide. Again, it is double displacement reaction. We get potassium iodide and barium bromide. Okay, potassium bromide with barium iodide, we get barium bromide and potassium iodide. Redox reactions, oxidation, addition of oxygen or removal of hydrogen. One more thing is there that we call as oxidation reaction, which is the loss of electrons. Okay, reduction means gain of electrons. One more thing, an oxidizing agent, I'll just add it here. An oxidizing agent, what it does, it gains electron. Oxidizing agent gains electron and a reducing agent loses electrons. Okay, just remember this. An oxidizing agent gains electron and a reducing agent loses electrons. Okay, now acid, how do acids react with metal carbonate, metal bicarbonate? You see, carbonate or bicarbonate, they have a carbon, right? So the gas released will be carbon dioxide. We get salt, carbon dioxide and water. When acids react with metals, again, when metal react with acid, we get salt and hydrogen gas is released. This is applicable for only two acids, HCl and H2SO4. With HNO3, the case is little different. When you talk nitric acid, only these two metals evolve hydrogen gas. Rest every metal gives water. Why water? Because nitric acid is a strong oxidizing agent. It oxidizes hydrogen to water. It oxidizes hydrogen to water. Okay, that's why we do not get hydrogen gas, we get water. Okay, but for magnesium and manganese, when they are treated with dilute nitric acid, we get hydrogen gas. Next is your metal with bases. When bases react with metal, we get salt and hydrogen gas. These are two important salts, sodium aluminate and sodium zincate. Now you look at their preparation. Because these three metals, zinc, lead, aluminum, they all are amphoteric. That means they react with both acids and bases. Now how do acid react with bases? Neutralization reaction depending on the strength. Strong acid, strong base, neutral salt. Strong acid, weak base, acidic salt. Weak acid, strong base, basic salt. Chlor-alkali process. Chlor-alkali process is very important. You take a brine, which is an aqueous solution of sodium chloride, and you pass electricity through it. You get sodium hydroxide, hydrogen and chlorine. Sodium hydroxide and hydrogen and chlorine. Now hydrogen is obtained at anode, and at cathode we get chlorine. Now how do you form bleaching powder? You have slaked lime, dry slaked lime you take. Okay, through this dry slaked lime we pass chlorine gas, we get calcium oxychloride and water. That is bleaching powder. Formation of baking soda and washing soda. So again, these three steps are for your solvay process. These three steps are called solvay process. Okay, what is the first step? So brine, if you add ammonia to it and carbon dioxide gas, pass carbon dioxide gas through it, we get baking soda. If we heat baking soda, we get sodium. If we heat baking soda, we get sodium carbonate. Okay, we get sodium carbonate. If we add 10 water crystallization to this sodium carbonate, we get washing soda. Just memorize these three reactions are your solvay process, right? First step, brine, add ammonia to it, pass carbon dioxide gas, we get baking soda and ammonium chloride, and then you heat this baking soda, you get sodium carbonate and water plus carbon dioxide. Then this sodium carbonate, add 10 water crystallization and forms washing soda. These three steps are called your solvay process. Then you have formation of POP, plaster of Paris, baking powder. Baking powder is a mixture of baking soda plus edible acid. So you remember only one, tartaric acid. So baking soda is baking powder is a mixture of baking soda and tartaric acid. Then you have formation of plaster of Paris. If plaster of Paris, which is plaster of Paris, gypsum, you take CaSO4.2H2O, which is gypsum, you heat it around 100 degrees Celsius, you get plaster of Paris. This is plaster of Paris. Calcium sulfate half H2. If you heat it above 373 Kelvin, you will get dead burnt plaster. Metals react with oxygen, form metal oxide. Metal oxides are basic in nature. Why? Because if you combine them with the water, you get base. Non-metal oxides are acidic in nature because if you combine them with water, you get an acid. Metals react with cold water, sodium, potassium, right? Metals react with hot water, magnesium, form metal hydroxide and hydrogen gases evolved. Right? Then you have some metals react with water vapors like aluminum, iron. They form metal oxide, not metal hydroxide. They form metal oxides and hydrogen gas. Right? Now amphoteric oxides, they react with both metals. Amphoteric oxide react with metals as well as they react with both acids and with bases. Both acids and with bases. Like, what do they form? They form salt plus water. Okay. Now roasting is heating in excess oxygen. Sulfide ores are normally roasted in presence of excess oxygen to convert them into their oxide ore. Calcination means heating a carbonate ore in absence of oxygen. We get metal oxide and carbon dioxide. Thermite reaction, very important. Aluminum react with iron oxide and we get aluminum oxide plus molten iron and lots of heat is released. That means this reaction is highly exothermic. When you combustion means you supply oxygen to it. Any hydrocarbon, right? Any hydrocarbon, we get carbon dioxide, water plus lot of heat and light. Then we have oxidation of alcohols. When you oxidize alcohol, alcohol gets converted into carboxylic acid. Any two agents we use for oxidizing agent, alkaline KMnO4 or acidified K2Cr2O7. Both are oxidizing agent. That means they provide oxygen. Oxidizing agent oxidizes others, reduces itself. Addition reaction is shown by unsaturated compound. They have double or triple bond. Unsaturated compound. This is hydrogenation, addition of hydrogen in presence of nickel catalyst. Vegetable oil or unsaturated compound gets converted into fat or saturated compound. Substitution reaction shown by saturated compound. We have all the single bonds, right? Any atom comes and substitute one of the atoms. So here CH3Cl plus HCl we get. Okay. Next is ethanol reaction with sodium. We get sodium ethoxide plus hydrogen gases evolved. This is a test for ethanol. Then you have dehydration of ethanol, which is if you heat ethanol at around 443 Kelvin and presence of hot concentrated sulfuric acid, we get ethene and water. And then you have reaction of ethanoic acid with sodium metal carbonates or metal bicarbonates. In case of one, which is this, in case of sodium metal, ethanoic acid gives sodium ethanoate plus hydrogen gas. In case of sodium metal, again ethanoic acid will give sodium ethanoate plus hydrogen gas. But for metal carbonates and metal bicarbonate, the case is same. Carbon dioxide gas is released. Carbon dioxide gas is released. This reaction is not given by ethanol. Okay, this reaction is not given by ethanol. Then you have esterification, saponification. Any alcohol combines with an acid in presence of an acidic medium, we get an ester. That is esterification. Saponification is the reverse of esterification. You take an ester and you heat it in presence of base, and that's how you get sodium salt of carboxylic acid and the alcohol. Okay. Now how do you take it? The H from the alcohol and the OH from the acid. These comes out as water molecule, and then you rejoin the remaining part. Okay. Remember this, alcohol, from alcohol you take the hydrogen and from the acid you take the OH. Okay. Very easy to remember because in alcohol the O is directly connected to carbon, difficult to break. So that's why the H bond breaks, OH bond breaks. Here carbon is double bonded to one oxygen, COOH, right? The structure is like this. So that means this bond is easy to break. Okay, then you have reaction of copper with carbon dioxide. Copper combines with oxygen. Copper dioxide, which is black in color, combines with carbon dioxide, we get green color. This is the corrosion of copper. Then you have photosynthesis and respiration. Very easy. Photosynthesis is an endothermic process because energy is supplied. You're supplying the sunlight, right? Carbon dioxide combines with water. We get C6H12O6 plus 6O2, right? That is glucose and oxygen. Respiration is the totally opposite of photosynthesis, right? In mitochondria it happens. We have glucose combined with oxygen. We get carbon dioxide, water and energy in form of ATP. Adenosine triphosphate. Now let's start with the all important chemical formulas. So firstly, this is the table. Just look at it once. You have sodium, potassium, silver, copper. The valence is also given, +1, +1, +1, +1. Then you have magnesium, calcium, zinc, iron, copper. These have +2, +2, +2, +2. Then you have aluminum, iron, +3, +3. Then again hydrogen plus hydride minus chloride, bromide, iodide. These have -1. Oxide, sulfide, -2, -2. Nitride is N-3. Okay. You know how to make the formulas, right? The valency method. Ammonium, NH4 positive, hydroxide, OH negative, nitrate, NO3 negative, hydrogen again same, H positive. Now hydrogen carbonate is HCO3 negative. Hydrogen carbonate is HCO3 negative. Carbonate is CO3 2 negative. Sulfite, SO3 2 negative. Sulfate 8 is there, so SO4 2 negative. Then phosphate is also PO4 3 negative. This is very important. Just go through it once. Okay. Now you have how to write the chemical formulas. You do nothing, you just write the cation first, then you write the anion. Cations are the positively charged species, anion are the negatively charged species, and then you write their valencies. Then you write their valency and then you crisscross it. Then you simply crisscross it. Aluminum has a valency 3. Why? Because we know here we are given aluminum has 3 positive. Oxygen has a valency of 2. Why? Because it is given here O2 negative. Okay, so we just crisscross aluminum 3, iron 2, so we get, that's why we get Al2O3. Next, again similarly for here, K positive, CO3 2 negative. So K has valency of 1, CO3 2 negative has a valency of 2, so you get K2CO3, potassium carbonate. Okay, now you have all these formulas, go through it once. MgO, ZnSO4, iron oxide, glucose, barium chloride, aluminum sulfate, barium sulfate, aluminum chloride, zinc oxide, all the formulas, right? Sodium hydroxide, Na2, sodium sulfate, calcium oxide. We have iron, ferric oxide, copper oxide is important, the color is blue. Ferrous sulfate, FeSO4, methane, that is also natural gas. Lead nitrate is important. Then you have nitrogen dioxide, lead oxide, lead chloride, copper chloride. Okay. Potassium sulfate, zinc carbonate, ZnCO3. Both has valency of 2. Zinc has valency of 2. Carbonate, CO3 2 negative, it also has a valency of 2. You crisscross it, we get ZnCO3 because both have 2, 2, right? We can take it common. Potassium hydroxide, zinc nitrate. Again, nitrate has a valency of 1. Zinc is 2 positive, nitrate is -1, -1. Then you have all these calcium bicarbonate, it is soluble, it is the soluble one. Okay, so if you add calcium carbonate, if you add carbon dioxide to calcium carbonate, we get calcium bicarbonate, which is water soluble. Okay, then you have bleaching powder, calcium oxychloride, methanoic acid, hydronium ion, H2O positive. This is sodium zincate, which is very important. Okay, then you have ammonium chloride, washing soda, gypsum, plaster of Paris, hydrated copper sulfate, has 5 water crystallization. One more name for it, which is blue vitriol. Okay, then you have sodium aluminate, aluminum oxide, cinnabar, HGS is an ore of mercury, lithium chloride, magnesium chloride, manganese dioxide, MnO2. Simple, you just remember, have to remember their valency. Copper sulfate, copper sulfide, that means copper sulfide. Okay, then you have from alkane series, methane, ethane, propane, butane, pentane, hexane. Similarly, ethene, propene, butene, pantene, hexene, octene. These are their structures. From alkyne, you have ethyne, propyne, butane. So the 2 carbon, right? See, for alkane, the first one is simple, 1 carbon, methane. Okay, but from your alkene and alkyne, we start with 2 carbons at least, ethene and ethyne. Why? Because carbon and hydrogen cannot have more than 1 bond. Okay, they can only have 1 bond. If you try to make 2 bonds, it is not possible because hydrogen does not have 2 electrons to give. It only has 1. Then from your carbon and its compounds, acetic acid or ethanoic acid, they are same. Chloroform is CaCl3, ethanol is CH3CH2OH, and methane is CH4. Sodium ethoxide, CH3CH2ONA. It is formed when ethanol combines with sodium. Okay. Ethanoic acid, again sodium acetate. This is when sodium metal combines with ethanoic acid, and this is ethyl acetate. This is an ester. Ethyl acetate. Then all the important chemicals we have: magnesium oxide, white color; copper sulfate, blue colored; copper chloride, bluish green in color; iron sulfate is green in color. Okay, just remember them, how they are formed. Magnesium combined with oxygen, magnesium oxide, white in color. Iron, copper sulfate, iron sulfate, copper sulfate is blue in color. Copper oxide, black in color, combines with HCl, we get copper chloride. Copper chloride is bluish green in color. Okay, then you have barium sulfate, white; zinc sulfate, colorless; copper oxide, black; lead nitrate, white; then lead oxide is yellow, and nitrogen dioxide is brown colored. Lead oxide is yellow, nitrogen dioxide is brown color. Okay, copper is reddish brown in color. Next, lead sulfate, which is white colored; aluminum sulfate, which is white colored. If a solid in liquid form, it is colorless. Okay, lead iodide is yellow colored, lead chloride is white colored, AgCl is white colored, Ag, silver, the color of silver is grey. The color of silver is grey. Everybody remembers this. Iron oxide is brown in color. This is rust, is also brown in color. AgBr is yellow in color, but Ag is what? Grey in color. Zinc chloride is white in color. Copper is reddish brown. Copper carbonate is green in color. This is the corrosion of copper, and silver is grey in color. Okay. How do you synthesize it? These are the reactions. This is the decomposition. Zinc chloride, zinc plus HCl. You got, this is metal and this is an acid. We get salt plus hydrogen gases evolved. Copper combined with oxygen, copper oxide, right? Copper oxide combined with carbon, we get copper carbonate. Now copper carbonate is green in color. Next we have iron. If iron is in +2 oxidation state, it is green in color. If iron is in +3 oxidation state, it is yellow in color. Okay, and last, copper +2 in +2 oxidation state, it is blue. For example, iron is in FeSO4, it is +2, so that's why it is green color. Okay, now my dear students, after your 10th, if you are planning to prepare for JEE, NEET, KCET, then we got you. We have the offline centers of Diksha Vedantu. Visit them once. And if you are planning for JEE, NEET, KCET, we are there for you. Okay, my dear students, do not worry, do not panic. You got this. How can we forget our biology portion, right? We have done physics, we have done chemistry. Now let's move on to the biology portion. From biology, we have prepared notes for most important diagrams regarding your biology. Yes, from your biology section, all the most important diagrams along with the important notes, my dear students. Yes, let's take a look at them. So you can see here, we have provided the notes. This is the diagram of a cross section of a leaf, right? And then we have stomata. These are all the important diagrams, right? You will see them. You have picture-based questions, right? You will see them in your science exam. So prepare accordingly. Okay. You have nutrition in amoeba diagram. Then you have human digestive tract, respiratory system, right? Human circulatory system, diagram of heart, right? With all the notes, what kind of questions might come in your exam, okay? So from your pulmonary, this is your pulmonary and systematic circulation, from structure of a nephron, all the diagrams, human excretory system diagram, right? Now we have prepared the notes. Now how can you download it, right? You need those for the quick recap. You know, if you're doing the diagrams, you need the notes, you need the diagram. So again, go in the description of this video, of this live, my dear students, yes, and from there you can download it. It has all the biology diagrams, it has all the physics formulas, it has all the important reactions regarding your chemistry portion, okay? So do not worry, just go and download it and be confident. Yes, you got this. You can score very well in your science exam, okay? You know it all, you have studied enough, right? Believe in yourself, be confident, okay? And yes, you got this. Okay, what else we have? We have neuromuscular junction diagram, then we have the reflex arc. These are all the important diagrams, keeping in mind the previous year question papers and the analyzing them. We have seen these diagrams come in your exam, okay? 1 or 2 questions will come from there. The human brain, how many parts are there, which part has which function, right? Midbrain, forebrain, hindbrain, right? Then you have the germination of pollen or stigma. What are the different part, what kind of fertilization, double fertilization, where is the gamete, female gamete, where is female gamete, where is the male gamete, right? Just to clarify, I'm not a biology teacher, so if I say anything wrong, that please do not take it in a bad way actually, because I am trying to help you all. I am giving you all the diagrams that are there required, that are very important for your biology section, right? So keep it in that way only. The notes are there in the description of this video. Go download them, okay? And it is going to help you for your boards, okay? So do not worry. And then what else we have? The longitudinal section of a flower, then we have female reproductive system, male reproductive system, then you have regeneration, right, budding and all, binary fission, spore formation in rhizophus, okay? And yes, you have all the physics formula too. Let's go there. Again, all the formulas and the SI units just in one sheet. This is one cheat sheet for your physics, right? Similarly, you have one for chemistry also, where you have all the important reactions, right? You see, all the reactions are there. Okay, just go download it from the description and do not worry. Do not worry, you got this, okay? We believe in you. Take care, all the best, and write your exam with confidence. You got this, okay?